from this finite period example is that I already put it here. Okay, so if you already know, like for a given period t and state s, if you already know what is the best outcome for the next state in the feasible set, then making decision will be much easier. Okay, so that is the concept here. And then we are going to the main dish, which is infinite period. Okay, now this is the infinite period consumption saving problem. Right, so what does this problem mean? So think of you are a household that you are going to decide how much to consume and how much to save for each period. Okay, so we write it this way. The function u here is the utility functions for you to consume final good ct here. Okay, and we also have the production functions, meaning that if your saving or your capital is kt for this period, and you can use it to produce final good, which will give you this amount, kt over power of alpha there. Okay, and we also have law of motions, meaning that this capital kt will depreciate at a rate delta here. So if you save something from this period to next period, it's going to depreciate a little bit. And that is the law of motions. So basically is your saving. So the f of kt is the productions you will have this period, okay? And after the capital is used, you will have some depreciation. So this is something left. So it's 1 minus delta times kt, and then you use part of it as your consumption ct, and this is the rest of it becomes the capital for tomorrow, kt plus 1, and we call it law of motions here. Okay, so that is the very typical classical consumption saving problem in economics field. Okay, right. So how to solve this very complex, complex problem here? Complicated, so complicated. So one way is like here. We'll try to list all the possibility we could have. Okay, so how to do it? Because originally the finite game tree problem is actually a discrete choice. Yeah, I should say like countable. But now is continuous. Like the choice set is continuous. So that means you will have infinite choice to make. Okay, so how can we do it? Okay, so it looked like this one. Right now, you stand at this point, which is t. The time is t equals to 0 here, with the capital you have on your hand, which is given k0 here. Okay, and you are going to decide how much to consume. Okay, so what is the feasible set or choice set look like? So you can either choose from choose from 0 to the maximum consumption you could have is that you're going to consume all of it, which is f of k0 plus 1 minus delta times k0. Okay, so this is the maximum consumption you can have, and this is the 0 consumption. And you can choose any point between this interval, right? These are all feasible set. And once you decide how much to consume, for example, like we decide not to consume, which is C0 equals to 0, then you will automatically get the capital in the next period, which is K1 will equals to, follow the law of motion over there, you just plug K0 into K and C0 into the CT there. You will get the capital stock for the next period. And again, standing at this point, t equals 1, and with the capital you have K1 here, you will have another choice set over there. Again, start from 0 to the maximum consumption you will have, and you are going to have infinite period. Okay? Okay. So you say that, okay, let's pick one path and continue. And then pick another one, continue. And then you compare the utility you will have, which is t from 0 to infinity. You collect all the possible consumption paths, and then you pick the one that will give you the maximum value here, which is impossible. Like, there's no one can do that, even for one single path, because it goes to infinity, right? So how are we going to deal with it? Okay, let me see, what do I have here? Again, recall that the finite gantry here. So if we at a period, say that period 3, with the capital stock K3 there, and we already know that the optimal value we will get from the next period is like once you reach that state, you will get the optimal value. Then the problem will be much simpler, because we only need to go to that specific state. Then we are going to automatically get the maximum value, right? So here is the same concept, which is value functions, meaning that this function will tells you that when you add period t with capital stock kt there, then this will represent the optimal value you will get if you reach that state at that period. Okay. So we can actually rewrite the whole problem into following way, which is the value function of period t at with capital KT here. This will, because it still maximizes the whole how to say that, still maximize your utility. So it's going to maximize the consumption, the utility you will get from current period consumption, and the future future value of your consumption path. Okay, here.